For lesson 6-3, we're going to find the sum of the angle measures of a polygon and the measure of an interior angle of a regular polygon. An interior angle would be referring to if I had a triangle here. An interior angle would be this angle right here. Obviously, we have these exterior angles like this one, but interior angle is referring to the ones on the inside. An equilateral triangle is obviously one with all three sides equal. So if I said that this was x, this would also be x, and this would also be x, then this would be an equilateral triangle. Equal angular would be the same thing. Equilateral, lateral means side, sides, and angular means obviously angles. So equal angles, equal sides. A regular polygon would be like an equilateral triangle. We'd also have a square. So we have our equilateral triangle. We have a square. That's a regular polygon. Regular means all sides are equal, and it means all angles are equal. So, you think about like a stop sign. A stop sign is a regular octagon. Okay, so we have 8 sides there on the stop sign, and this is a poor picture of it, obviously, but we have 8 sides, and all sides are equal, and all angles are equal. When we talk about this mini lab here, okay, when we have 3 sides on a polygon, obviously we have a triangle. Okay, how many triangles do we see? Well, obviously it's just one. Okay, now something that we need to know is that how many degrees are on the inside of a triangle? There's 180 degrees, and that can be figured out using this formula right here, because there's one triangle, so there's 180 degrees per triangle on the inside. So like this one plus this one plus this one would equal 180 degrees. Okay, with 4 sides, we can draw from one diagonal, okay, and that makes 2 triangles. So because we have 2 triangles, we do 2 times 180, so therefore we have 360. So this angle plus this angle plus this one equals 360 degrees. If you think about like a square, each angle is 90 degrees, and 4 times 90 is 360, so that does make sense. Now, a 5-sided shape, that would be a pentagon. Okay, so 3 means tri, 4 means quad, 5 is penta. All right, and if we draw the diagonals from one angle or from one vertex, we can make 1, 2, 3 triangles, and 3 times 180 equals, and well, we can get our calculators out. 3 times 180, that equals 540 degrees. So every pentagon has an interior angle sum of 540 degrees. Now, if we draw a hexagon, you can kind of see the pattern. 1, 2, 3. We're expecting it to be 4. Let's go ahead and draw it. From this vertex, it would be 1 line, 2 lines, 3 lines. This line's already here, but now look, we have 1, 2, 3, 4 triangles. So now we'd have to do 4 times the number of degrees inside of a triangle, which is 180 degrees, and then we can multiply 4 times 180 degrees to get 720 degrees. It's the interior angle sum of any hexagon. So here it says, write an algebraic expression that could represent the number of triangles in an n-sided polygon. So we want to say it's n sides. Okay, so obviously the polygon, we don't know what it's going to look like because it's got n sides. Take a look here. If we have 3 sides, we have 1 triangle. 4 sides, 2. 5, 3, 6, 4. So it's always n minus 2. All right, there's always 2 less triangles than compared to the number of sides. And then we always took this number and multiplied by 180. So if we take n minus 2 times 180, that will equal the sum of the interior angles. So that's kind of our expression right here, is n minus 2 times 180. So if I said, how many degrees are on the inside of an 18-sided shape? You would just plug in the number 18. 18 minus 2 is 16. 16 times 180, and that's your answer. All right, so on the next slide, it gives you our formula right here, n minus 2 times 180. So that's our formula that we'll want to keep track of, okay? Looking at an example here, it says, find the sum of the measures of the interior angles of a hexagon. Well, before we go to that, let's go here and make a little list, okay? Tri means 3, quad means 4, penta means 5, hexa means 6, hepta means 7, octa means 8, nona means 9. So these would be like triangle, quadrilateral, pentagon, hexagon, heptagon, octagon. Gon means sides, so I could say gon means sides. All right, nonagon, 9 sides. All right, and then we have deca, that means 10. 11 is just 11 gon, okay? And then 12 is actually dodeca. And then after that, we just say 13 gon, 14 gon, and so on. Okay, so after, including number 11, and then after 12, we would just say the number of sides, and then the suffix gon. So it says, find the sum of the measures of the interior angles of a hexagon. Okay, hexa means 6. So if I have n minus 2 times 180, all right, I'm going to do 6 minus 2 times 180, which is going to be 4 times 180. Now again, it's looking for the sum here. We're not looking for just one angle. We're looking for the total sum. So if I do 4 times 180, that's going to give us 720, which I know we found before, but it's good for us to check that. So we have 720 degrees is the sum inside of a hexagon. So 720 degrees would be our answer. Find the sum, again we're looking for the sum, the total, of the measures of the interior angles of a heptagon. So again, hepta means 7, and I wrote that there for you. So again, n minus 2 times 180, and then if we do 7 minus 2 times 180, that'd be 5 times 180. We jump onto the calculator here. All right, let's try those again. 5 times 180, we'll get 900 degrees. If we add up all of the interior angles of a heptagon, a 7-sided figure, that total would equal 900 degrees. A designer is creating a new logo for the bank. The logo consists of a regular pentagon surrounded by isosceles triangles. Find the measure of an angle, of an interior angle of a pentagon. So a regular pentagon means that all of these sides are equal. Okay, and then they said isosceles triangles, meaning this side and this side are equal. Okay, isosceles means that two sides are equal. We don't really need to worry about the isosceles triangles here because it says find the measure. It doesn't say the sum. It says find the measure of an interior angle of a pentagon. Well, first we have to know how many degrees are on the inside of all of the angles. So this one, this one, this one, this one, and this one. And we're not going to, take out any measuring tools like a protractor at all. We're just going to use our formula, n minus 2 times 180 Okay, a pentagon has 5 sides. So we're going to do 5 minus 2 times 180. So that'll be 3 times 180. So 3 times 180 should give us 540. So 540 degrees is the total sum. Okay, so all 5 of them added together should be 540 degrees. However, we don't want the total. We want to know the measure of n. N represents 1. So now what I need to do is take 540 and divide by 5. And the reason I can do this is because it is a regular pentagon. That means they're all equal to each other. So 540 divided by 5 will give us our total answer per angle. All right, so we're going to have 108 degrees per angle. Okay, so if they're all 108, all of them together would equal 540 degrees. So 108 degrees is our final answer for this question. We had a couple steps to do. We had to find the total number of degrees, and then we had to divide by how many sides to find how many degrees per angle. Michelle is designing a new logo for the math club. She wants to use a regular, meaning that all the sides are equal and all the angles are equal, nonagon. Remember, nonagon means 9, okay, as a part of the logo. Find the measure of n interior angles. We just want to know one of them, not all of them. So I'm going to do n minus 2 times 180. The reason I want to do this is because I got to find the total sum before I can figure out 1. So I got to do 9 minus 2 times 180, which is going to be 7 times 180. And now we got to find the total sum. 7 times 180 degrees is 1260. So there's 1,260 degrees in the entire thing. Now we need to take 1260 and divide it by 9. The reason we can do this is because it's a regular nonagon. So let's take 1260 divided by 9. So there are 140 degrees per angle. All right, so hopefully that's making sense. We need to find the total sum of all the angles by using this formula right here. And then once we have the total, we can divide it by 9 because a regular polygon has equal angles. So since they're equal, we can just divide it by 9 and we're going to get 140 degrees per angle. So that means this one's 140, this one's 140, this one's 140. They're all 140. So 140 times 9, if we were to do that, we would take 140 times 9, we would get 1260. So that's how it works, back and forth. We can do it either way. So that's our last example for today's lesson. Hopefully that'll help us get started with our homework.